Right, so in our previous lesson, we were looking at mappings. Mappings were where we were taking an input, we applied some kind of mathematical rule to it, and the result was an output. And for these mappings, we could either represent them as a mapping diagram. We looked at how we could represent them algebraically, and finally we looked at how we could represent them graphically. Then we also looked at different types of mappings that we can get. We can get one-to-one mappings, so one input for every output. We can get many-to-one mappings, where we can have multiple inputs that result in the same output. And then finally we get one-to-many, where we get one input which can result in multiple outputs. So we're just going to expand slightly on that today, and we're going to look at a special group of mappings called functions. So again, same thing, we're going to take inputs that produce outputs, except this time to define a function, we're going to say that a function is a mathematical rule that takes inputs, but very importantly, it produces exactly one output for each input. So looking at the ones we looked at yesterday, you can already see that there are only certain types of mappings that are classified as functions. So if we have a function, or if we have a mapping that results in only one output, the two ones that come to mind are one-to-one functions or one-to-one mappings and many-to-one mappings. So these mappings are what we call functions. So in other words, a one-to-many would not be classified as a function. Now we can express these functions similar to the way we express mappings. So if we take the mapping x is mapped onto x plus 1, if we wanted to express this as a function, we could express the function as function x or f. X is mapped onto x plus 1. And usually we will say that x is an element of the real numbers. In other words, we're just saying that it could be any value of x. So integers, rational, irrational numbers, etc. An alternative way of expressing a function is with function notation, f of x equal to x plus 1, and again we could express that x is an element of the real numbers. Now if we consider a function that exists, especially a one-to-one or many one-to-one function, there are two very important concepts that we need to know about them, and those are their domain and their range. So very simply, the set of input values of a function are called the domain. And the set of output values of a function are called the range. Now, we will look at these two in more detail as we go through some examples, but it's very important to understand that the domain is obviously going to affect the range, right? Because the input in a function is considered the independent variable. Right, it's independent of what happens to the mathematical rule. We take a variable, put it into a mathematical rule, and the output is dependent on whatever we put in. Right? So therefore, the domain is the input, it's independent, and the range is dependent on whatever the input value is. So let's explore this concept with an example. Here we have a function f of x equal to 2x minus 1. X is any real number, and very importantly, we are given a domain restriction, right? So we're saying we're only interested in the values of x between -1 and 3. Now the first question is actually quite simple. They say write down the domain of the function f. Well, they've stated the domain, and so we can just simply state it again. Right? These are the only values of x that we are interested. Remember, in our function, x is the independent variable, and so it will set the domain. The second part says sketch the graph of the function f. So because the function can only exist between a certain a range of x values, we want to know the value of the function at the edges of these two domain restrictions. So what we'd like to do is take function f and say, well, what is it equal to when x equals 1? So we'll get 2 times minus 1, and we'll get negative 3. And likewise at the other end, we can say, well, what is the function equal to when f is equal to 3? And we can say 2 times 3 minus 1, and we will get 5. Now we can have a look at the function, and you see that the function is just a linear function. It's just a straight line, right? And the y-intercept is going to be minus 1. And very simply, we can go from negative 1, 3, which is down over here, and we want to go all the way up to 3, 5, which is up over here. Okay, we will put those coordinates in. And there's our sketch of the function. Right, the next part of the question says state the range. Well, the range is dependent on the domain. So what is the domain? Well, if we have a look at the graph, we can say that the domain is the set of x values that we are restricted to. So we were restricted to minus 1 and 3. So this is the domain. And because we've set a domain restriction, you can see visually that we've now restricted the range of this straight line as well. The range of this straight line has been restricted between these values over here. So this is the range of the function. It's the output values that we've been limited to based on the domain. And we can see that these range between negative 3 and 5. And how we write this is the function can exist from minus 3. Right, and what is the function? Well, it's not y equal to. The variable is x, and the output is the function f of x. And so we will use f of x, and we're only going up to 5. So that would be the range of this function. Okay, let's have a look at another example. Here we have a quadratic function. Okay. It's been given in completed square format, and the first thing we notice again is that we have a domain restriction. So we only want this function only exists between 0 and 6. So they want us to sketch the graph, right? And the first thing we look at this function and we say, well, this is a quadratic. A quadratic has two different shapes depending on the coefficient in front of x. It can either be a smile or a frown depending on the value, and we know that from inspection this is going to be a positive quadratic. And one important thing to note with quadratics is they have either a minimum or a maximum value, right, because of their shape. We have a positive quadratic, so we have a minimum value. And what we want to do is we want to work out, is this minimum value going to be somewhere inside my domain restriction, right? And the easiest way to work out the minimum value of a quadratic is having it in completed square form. And lucky for us, that is exactly how it's been written. So if the quadratic is in completed square format, the minimum point or maximum point, depending on the quadratic, is the value inside the bracket, right? The opposite sign, so in other words, our minimum value would be 2, not negative 2, and the output, or the value at the minimum point would be 3. So that's the coordinate of my minimum point. And I can see that that falls within my range. So I'm going to have the minimum value somewhere inside my range. Okay, the next thing we want to consider is what are the values, the output values at either end of the domain restriction. So what is the output going to be at 0? So at 0, we're going to have minus 2 squared plus 3, and that's going to give us 7. And at 6, we're going to have 6 minus 2 squared, so 4 squared plus 3, and that's going to give us 16 plus 3, which is 19. Okay, at this point we have all the information that we need to draw the quadratic. Okay, so we know that the quadratic is going to have some shape like this. Okay, we're not going to have the whole quadratic because of this range restriction. So we can start putting in the coordinates that we know. We can say that we know that the y-intercept is going to be at 7. We know the minimum point exists at 2, 3, so somewhere over here. And at the value 6, we have a output of 16. So that could be somewhere up here. 19, sorry. And now it's just a matter of joining the dots. Right. Based on the sketch, we can now actually find the range. Okay, so remember that the domain, we were restricted with the domain between 0 and 6. And because we had a domain restriction, we now have a range restriction. And visually we can see that this will be the range of the function. Our lowest value is going to be 3, and our greatest value is going to be 19. So 3 and 19. So the range of the function is between 3 and 19. So very important, you'll notice that we don't use y, we don't use y equal to anymore. We say that if our input is x, the output is a function.